This question says, a slow environmental reaction has a half-life independent of the initial concentration, so it's a first-order reaction, of 455 years. It says, how long will it take for 22.3% of the sample to react? So the only half-life equation that's independent of the concentration, said another way, it doesn't have the concentration of A0 in it, is the first-order half-life reaction. So we know this is a first-order reaction. So T1 half is equal to 0.693 over K. Well, in this case, we actually want to find the value of K, and then we can use the integrated rate law to find how long it'll take for 22.3% of the sample to react. So to do that, what we want to do is plug in for T1 half 455 years equals 0.693 over K. So cross multiply K times 455 years equals 0.693, and divide by 455 years on both sides. K equals, and when you do that math, you find that K is equal to 1.52 times 10 to the minus 3 per year. So now we know the value of K. Now we can use the integrated first order rate law in order to solve this problem. And the integrated first order rate law is the ln of concentration of, we'll just call it A, at some time is equal to negative KT plus the ln of the concentration A initially. So what we need to do is now figure out the concentration of A at some time and the concentration of A initially. So to do this, we need to use this 22.3%. So we want to find out how long it'll take for 22.3% of the sample to react. Well, if we think about this as a number, this is 0.223. And this is how much reacts. So that means that 1 minus 0.223, or 0.777, remains. So we need to figure out how much remains. So 77.7% of the sample remains. So that will be the concentration of A at some time. The concentration of A0 is 1. So we can use percentages in this way. If you want, you could put in 177.7, but it's easier to put in 1 because the ln of 1 is 0. So if we do this, we get the ln of 0.777, the percentage, if you will, as a number, of the A that remains, equals negative K, which we have, negative 1.52 times 10 to the minus 3 per year, so negative of this value, times T, that's our variable, plus ln of 1. So when we do this math, the ln of 0.777 is negative 0.252 equals negative 1.52 times 10 to the minus 3 per year plus ln of 1, which is 0, so just plus nothing. Divide both sides by, this is times T, divide both sides by negative 1.52 times 10 to the minus 3, divide by negative 1.52 times 10 to the minus 3, and you find that T is equal to 166 years. So it will take 166 years for 22.3% of the sample to decompose or react. In the next question it says, if there were initially 2.3 times 10 to the 18 molecules of the reactant, how many molecules will remain after 9,980 years? So we already know that K for this particular reaction is 1.52 times 10 to the minus 3 per year. And we're going to use the exact same equation. The ln of the concentration of A at some time equals negative KT plus the ln of concentration A, 0. So in this case, we know how many molecules there are, which is not exactly a concentration. But if the volume is constant, an assumption that we need to make, then molecules are directly proportional to concentration. So we don't need to convert it to moles and then divide by a volume to find molarity, because if the volume is constant, the number of molecules and the concentration will be proportional. So we can just plug in the molecules. So let's do that. Let's plug in what we know. Well, what we don't know is the concentration of A after the time. So the ln of the concentration of A after some time is equal to negative K, which we know K, 1.52 times 10 to the minus 3 per year, times T, which is 9,980 years, plus ln of the initial concentration, but in this case we're going to plug in molecules, 2.30 times 10 to the 18. Now we're going to do the math. The ln of concentration of A at some time equals, well, we multiply these two numbers together and we get negative 15.17. Then we use our calculator to take the ln of this and we get 42.28. Now we get the ln of the concentration of A at some time is equal to 27.11. So I just simply added these two numbers together. To get rid of the ln, you hit the shift or the second key on your calculator and you take e to the value. E to the ln gets rid of it, and the concentration of A at some time is equal to 5.94 times 10 to the 11 molecules. So this is the concentration of A after some time.